Hey guys, welcome back to Consistent Code. So today's problem of the day is array removals. So what we need to do is that we are given an array of size n and integer k. So we need to remove some array elements such that after removing those elements, the minimum and maximum elements absolute difference in that array is less than or equals to k. For example, if we just consider this case only, that our n is 9 and k is 4. So in this case, what I can do, if I just take the maximum, that is 20, and the minimum element, that is 1, then 20 minus 1 is a 19, right? But what I want is that my maximum minus minimum should be less than or equals to 4. So what I can do, I can just remove this 1. Okay, so now my maximum minus minimum, that is 3, is 17. I need to reduce it even further. So just see, if I will remove this 20, I can get better results, and by removing minimum element, so I can remove this 20. So now after removing this 20, I have 17 minus 3. So even now I am having 14, so I need to remove even more, so I can remove the 17. Now 12 minus 3 is basically 9, right? So if now I can, even now it is greater than 4. So what I can do, I can either remove 3 or we can remove 12. So if we remove this 12, then we will have 11 minus 3, and that is what we can say, 8. Now if we remove this 11, then we have 10 minus 3, and that is a 7. So we just removed 5 elements, but we need to remove even more elements in this, like this. So let's go to one step backwards, and instead of removing 12, what if I remove this 3? Then the case would have been 12 minus 4, that is 8. And now if I remove this 4, then I get 12 minus 9, that is a 3, which is less than 4. So the minimum steps I got is from this case. So minimum steps are 5. I need to remove 5 elements. Okay, now I hope you understood what we need to do. But how to solve this problem? So to solve this problem, we can just follow a simple approach. So what we will do, um, first of all, it's not necessary that the given array will be sorted. So this is not sorted. In this case it was sorted, but it's not necessarily sorted. So first we need to sort this array. Okay, and what our question is saying, that it's asking us to solve this problem in O and log n time complexity. So that makes our time complexity n log n if we are sorting it. So by doing this only, we are having time complexity n log n, but that does not solve our problem. What we can do further? So furthermore, what we can do, we can just like if I want to remove some elements, and I want, so what I will do, I will obviously remove in the sorted array either from the start or from the end. But how to choose which element I need to remove? So I can just consider cases. Let us say we are having this complete array, um, this whole. Now what if I say that I want to choose this 20? Okay, so I can find a place here using binary search. Okay, using binary search I can find an element that is such that 20 minus that element is less than or equals to k. Okay, so that could satisfy our condition, right? and I can, since this array is sorted, I can do this in log n time complexity, right? Now, so I can just do this for 20, and 20 minus 4 is 16. So I want an element that is 16 or greater than 16. So what I can do, I can just subtract one more from it and find upper bound for 15, right? So I can get any element that is 16 or greater than 16. So I will get an element that will be 17. So I will get this element. So from upper bound, I can get the index here. This will be my index. And so how many elements did we remove? This is my ith index. That will be this, the complete array elements minus this part. So what will be this area? This area will be I minus IND plus 1. These elements are the chosen elements. So the elements that were removed will be n minus these elements, right? So that's what we can do. And this will this is one case. So in this case, we get these elements that were removed. But is this the optimal answer? So no, we need to check for other cases also. In this case, what we did, we started from 20. That is, we are considering 20. But what if I say I'm removing 20 and now I'm starting from 17? So I will consider my I here and find 17 minus k minus 1's upper bound. That is 17 minus 4 minus 1. That is 12. So I will just find upper bound for 12. And that will again be this 17 only. So I will, in this case also, I removed elements which were even greater than the last time. And what will be my answer? I will always consider the answer as minimum of the previous value of answer and the new value of answer, right? In this case, the previous value will be considered. So now I will again check for next element, that I am removing 17 also, and I am starting from 12. So I will find the upper bound for 12 minus 4 minus 1, that is 7. So the upper bound for 7 will be, you can say, this element. So this will be my IND index and this is my I. So the number of elements that were chosen were this. So this will be I minus IND plus 1. So the number of elements that were removed will be n minus I minus IND plus 1. And this will be my optimal answer. And now what will be the time complexity of this thing? So initially, as we know, first step was we sorted the array. So the time complexity was n log n that the question was asking. Now the second thing which we are doing is that for every element we are finding upper bound for. So for n elements we are finding the upper bound for n minus k minus 1. So n log n. So what becomes the overall time complexity? N log n plus n log n. So that is basically n log n only. N log n only. So that satisfies our answer. So now let's code it and see how to implement it. So first of all, what we can do, we can just check if we have only one element in the array. Suppose n is the size of the array. Now if there is only one element in the array, then that element is the minimum as well as maximum. And so the n, we can say maximum minus minimum, will always be 0. And in the constraints we can see that we want k greater or equal to 1. So in this case, always my answer becomes 0 because we don't need to remove any elements. As max minus min becomes 0, that is always less than 1, which is the minimum value of k. Having done this, the first step was sorting the array. So we can just sort this array using this sort function. Now once we have sorted this array, we can just create an answer variable and initially consider that we need to remove all the elements. That will be the worst case, right? So now what we can do, we can start iterating from the last element as we discussed till only 2 elements are left, and just check for the upper bound of what will be my index. Index will be the value of that element, that is upper bound of. So we can just say upper bound of array dot begin to array dot end And for what is the value that we want to find? We want the value array of I minus k minus 1. We want upper bound for this value, and since we want index, we need to get subtract arr dot begin to get the index of that value. Now that we got the index, so what will be the elements that we chose? That will be I minus index plus 1, right? So what were the elements that were removed? That will obviously be n minus e, right? Because there were total n elements. So if e were initially the elements we chose, so now I'm replacing e by the elements that were removed. And what will be my answer? Answer will obviously be the minimum of answer and the current removed elements. And finally, I can just return my answer. So now let's just submit our code. And we have solved this problem successfully, and I hope you like this video. And if you like this, make sure you hit the like button and subscribe to the channel, and I will see you tomorrow with the next problem of the day.